Right. Before I started doing Go 3 years ago, I have to be honest, I didn't read that much open source code. I know. But often, it wasn't just worth the effort of trying to understand it. But now, though, I'll browse through an interesting library just out of pure curiosity. And so Go has made other people's code so much more accessible to me. If I had to write an HTTP router for some reason, there's a fair amount of projects out there that I could draw inspiration from, right? But there's also the kind of software that you won't probably ever see end up on GitHub. Software that's so specific, in fact, that it solves problems that people yet didn't know they had. And that requires solutions so complex that it requires multiple teams working on separate subsystems. And if I was that one writing that software, where could I go for inspiration? So my name is Marcus Olsson, and I work as an infrastructure developer at Klarna, and previously as a consultant at Ceteris. And during my time as a consultant, I had the opportunity to work on both complex business systems as well as microservice architectures. And the most difficult discussions we had at those clients weren't really about software, but about trying to understand the business we were trying to implement. But maybe that's not that surprising, really, when you realize that what many of these teams are really trying to do is to understand and successfully model a real-world system or process. And very often, that system or process is not really technical in its nature, right? Banks, insurance companies, traveling agencies, libraries, logistics companies, I would argue that none of these has anything to do with software. They've been around since software was even a thing. And because of this, they typically have these people running around that know a lot about the business, but not necessarily a whole lot about building software. To them, software is simply a means to an end. How's interest being calculated? Or how do you earn bonus points? How do you estimate the risk of handing out a mortgage loan, for example, right? These problems are fundamentally not software problems, and they require us to collaborate with these business experts that may or may not know a thing about software. Eventually, though, that software that we create becomes a distilled model of that business. And while the company might decide to open source in-house tools and libraries, the core domain is most likely what makes your product competitive. And you're not very likely to put it up for public display on GitHub. And for these reasons, there's many awesome tools and libraries out there, but not a whole lot of examples of these core business services, right? But having such an example could help support the discussions on enterprise software within the Go community, as well as help other enterprise developers that are new to Go to get up to speed on the best practices when writing a service in a new language. But how would such an example look like? And where would we start if we were trying to implement one? Well, if we are to provide an example of rich with intricate behavior and business logic, one good place to start is the book by Eric Evans, released in 2003. And the practice of domain-driven design has increasingly become an essential part of building modern business systems. Domain-driven design rests on this fundamental idea that most of the complexity in software lies in the domain, the business, and not in the technology. This means that software is driven by this model of the domain and not the other way around. And if this is true, it means that we need to have a close collaboration between those who know the business, the domain experts, and the developers. Identifying the important concepts in the domain and the language we use to talk about them is hard work. And then trying to express that language in code is even more difficult. And so, while a lot of what domain-driven design is about, the way we collaborate with the domain experts and about the language we use, a lot of developers have felt the need for an example of how the code would actually look like. And in fact, in 2009, in a joint effort with Eric Evans himself, Ceteris wrote a sample application with the purpose of demonstrating an example of a running application based on the ideas from domain-driven design. And the sample application was made to show you how it could be done, right? Not just tell you. And it was originally written in Java, but has since been ported to a number of languages throughout the years. And the sample application is based on the examples from Evans' book, where he explains the concepts of domain-driven design using the domain of container shipping. And I'm not talking about Docker containers here, but the kind of containers you would use to transport these millions of mobile phones across the world. And the application they built lets you book and track these cargoes, as well as reporting incidents along the way to their destination. Now, this is starting to sound like something we could use. Not only does it provide us with a domain, it is a domain that is well known to a lot of enterprise developers, which might even offer a bit of leverage when the team is trying to decide whether to write their next service in Go. And so while I don't think that the domain-driven design community feels the need for yet another port, I do believe that it could prove useful to discussions in the Go community. As you might have guessed by now, I started porting this sample application to Go a while back. And my initial goal was to rewrite the Java application in Go to the point where I got the test passing. But as you can imagine, when just straight off porting Java to Go, well, let's just say it wasn't worth calling home about. But that was fine, because I wanted to be in a position where I could refactor towards something more idiomatic, rather than completely rewriting it from scratch. And in the process, I decided I would turn the monolithic Java application into a more service-oriented Go application, which resulted in 2 backend services. We got GoDDD, that contains the core shipping domain, and Pathfinder, a routing engine that would have been developed, typically would have been developed by another team. And the shipping service queries this routing service for suggestions on how to route the cargo. In these types of business systems, you typically see several services collaborating, so a sample application would definitely have to demonstrate this interaction. There's also an Angular front end to complete each use case with a graphical interface, as well as to let developers get a feeling for the domain. There's a demo available here for those who want to play around with it. But I thought we take a closer look at the shipping service, because in the end, this is where we're gonna blow our competition. And so if you bought into the idea that the domain is the most important part of your application, the multi-layered architecture that we've come to learn becomes a bit annoying, right? How you persist things suddenly is not the most important part of your application anymore. So why should the domain model depend on the database? Another way of visualizing your application is to keep your core business logic dead center, and where you're only allowed to depend on the inner layers. This architecture has been called by a number of names, like hexagonal architecture, ports and adapters, and clean architecture. But they're all based on recognizing the importance of the domain model. And in this diagram, each side represents a port into or out of our application. For example, an incoming HTTP port can make requests to our application layer, where it gets handled and then maybe even persisted to Postgres through an outgoing database port, while traveling into and out of each layer. Also, the closer you get to the center, the more likely you are to involve other people. right? If you introduce a new logging library, you'll probably deal with it within your team. But if you're implementing new domain logic, you'd probably want to bring in the domain experts to make sure we're doing the right thing. But if the domain layer doesn't depend on the database anymore, how are we able to store our domain objects? Well, the key here is the concept of inversion of control. Each layer defines interfaces that allow outer layers to inject these concrete implementations, leaving the control of which implementation to use to the caller. And this is crucial if we want to keep unnecessary dependencies out of our domain model. A simple example would be the domain repository, where the domain model exposes an interface but leaves the implementation to the infrastructure layer so that we can push the choice of persistence technology from our domain model. We can easily change the database without making any changes to our domain layer. And this is a big win, because after all, this is where the business logic central to your application is defined. This is where you'll define the behaviors and the business rules that your application must obey. This layer is the reason this application even exists. It's the engine that drives it. In fact, since this is something that's unique to your application, you won't see much use of third-party packages here. If you think about it, it's not that surprising, since you're hopefully the only one solving this particular problem. Ideally, the domain model is not allowed to depend on anything but the standard library. This, combined with a small language like Go that enforces a ubiquitous coding style, really allows you to focus on the domain rather than who wrote the code. This is definitely where you want readable, understandable code. And most of the behavior I'm talking about here will be contained within your domain objects. And two types of domain objects commonly mentioned in domain-driven design are entities and value objects. And I know that these are two loaded terms, so just to give some definition, by entity, I mean a thing that is defined by its identity. Right? Two people with the same name living at the same address are still two different people. A value object, on the other hand, is something which identity we don't really care about. If you give me 10 pounds in exchange for the same amount, the identity of the banknote is not really interesting, as long as it's got the same value. And Go has a very nice way of mapping these concepts to code using method receivers. In the sample application, one example of an entity would be the cargo object. A cargo may be updated along its way to its destination while keeping its identity. And we can communicate this using pointer receivers that allow us to mutate the object throughout its life cycle. An itinerary, on the other hand, which describes a route to the destination, doesn't really have an identity. It's just a list of these origin-destination pairs called legs. It's really just a specification. And in this case, we're really not that interested in its life cycle. So instead, we use a value receiver to communicate its immutable nature. And while it might be tempting to see these entities and value objects as simple DTOs, they don't just carry data. They are the main tools we have to express these important concepts from our domain language. And if you take a closer look at the sample application, you'll see that each struct in the domain layer have fields that are named with care to reflect the terminology that we use in the conversation we have with the domain experts. And so while the domain layer defines this framework of behavior and the rules by which we must play by, we don't really want to expose it all to the user. And so the application layer formulates these use cases that our users are interested in by orchestrating these domain objects. Another responsibility could be to define interfaces for publishing, for example, important domain events. Right? The application should be able to notify our customers when their cargo has been misdirected. But here, we don't care if it's by email or SMS. One of the main players in this layer, though, are the application services. They define the operations available to our users. Book a meeting, apply for a loan, cancel order. These are all examples of use cases typically exposed by application services. This is an example of an application service from the sample app. And these are two operations related to booking cargoes. Right? Book new cargo registers a new cargo in the system, but it won't actually ship anything until it's been assigned to a route using the assign cargo to route method. And methods like book new cargo that creates new domain entities will typically involve some initial validation before we create the cargo and then store it in our domain repository. And here we see the start of the cargo lifecycle. But many methods will instead operate on already existing cargoes, like the assign cargo to route method. And these methods will typically take a reference to the entity along with any additional arguments. And similar to the previous slide, we validate our inputs, we then load the cargo and execute some behavior on it before we store it again. And indeed, these are two patterns that you'll see in most application services. Finally, we have our infrastructure. This layer is responsible for communicating with the outside world. And by, for example, adapting requests to our application layer. It will contain adapters for stuff like database access, metrics, transport protocols. And if you listen to Peter this morning, there's at least 40 terrible things in this layer that you have to take into account here. And to most applications, this layer is a necessary evil. But without it, nobody would be able to make much use of what you built. And because the problems here are problems that almost all of us face, this is also where most of your third-party packages will be. And the cool thing about structuring your application in this way is that it really leaves you pick and choose these third-party packages in your infrastructure layer without really affecting your application layer or domain logic. And so while nothing so far in these slides have been in any way tied to a third-party package or library, one cool project that I found, though, is GoKit. And so what I like about GoKit is that it defines this set of well-designed interfaces that we can use in our application layer that allows us to inject the infrastructure we need for dealing with the common challenges in distributed systems like logging, metrics, circuit breakers. And one thing in particular that caught my interest in GoKit was the way it promotes decorating your application service using type embedding. Here's an example of how we could add logging to our booking service, for example. Because we're embedding the original service, the logging service will automatically fulfill that interface. And we can call it from within each method we override. And the logger here is actually a logger provided to us by GoKit. We're free to choose any logging package out there as long as it's implementing that interface. Again, separating the infrastructure from our application. And while we could have named our packages according to these layers, and in fact the original Java application is organized in this way, it would be a real pain to use. And I think it's important here to point out that while this type of architecture helps us reason about the concerns and responsibilities, it needs to be adapted to the context it's being applied to. And speaking of context, the package names on this slide doesn't really provide us with any that's meaningful to us. And we would probably need to create additional sub-packages within each and every one of these. The purpose of the application becomes lost in directories. So how should you organize your application? Well, domain-driven design also mentions the use of modules. And while they're essentially used for organizing code, more importantly, they tell the story of the domain at a larger scale. And the name of the module actually becomes a part of the language we share with the domain experts, and therefore also becomes another tool in the conversations and discussions we have with them. And it turns out that using Go packages as domain modules makes for a rather pleasant code to read. These are 3 domain packages from the sample application. And to the right, you'll see some examples of how the package name lets us set the context. So while a number is typically something very generic, in the context of a voyage, it's something very specific. Another consequence of naming our packages based on the concepts within our domain is that we suddenly get a pretty good feeling of what the application does only by looking at the root directory. Also, I found that since each application service typically groups functionality related to a certain use case, they're pretty pretty self-contained. Right? Tracking, booking cargoes, as well as logging incidents may share a domain model, but the stakeholders for each use case may very well be different, so it makes sense to let them evolve individually. And dependencies that we bring into our infrastructure layer are not allowed to be a part of the application layer nor the domain layer. Instead, they get their own package. And these packages will typically contain adapters like these ones that can be injected into either the application or the domain layer. So when deciding on package naming and contents, take a moment to think about what the next developer expects to find when she takes a look inside it. Right? A package called infrastructure doesn't really provide us with a good clue. But one named Postgres would tell her that she's probably going to deal with some SQL queries. Finally, we wire it up in our main package, where everything comes together to form our application. It basically becomes a matter of configuring your third-party packages and then injecting them into your application services. Here you'll see how the pattern I just showed you lets you add things like logging and metrics to your application by decorating the service with each concern. As an added bonus, based on the analysis of the most popular package names on GitHub by Francesca a couple of months ago, I present to you the most generic Go application you'll find. I have no idea what it does. Hopefully, though, you're not writing the same application as everyone else, but a very specific one that's unique to the problems you're facing. So let's name our packages so that I actually reflect the problems they're made to solve. So should you head home now and rewrite all your services in this manner? Maybe. Having to think about multiple abstraction layers comes at a cost of increased complexity. Not all services benefit from this type of architecture. One way to tell would be that the service contains a good amount of complex behavior that comes from the discussions with non-software people outside your team. These applications typically evolve from such discussions, and it's vital that those changes are made orthogonal to your infrastructure. Is the sample application complete? No, and it probably won't ever be. The challenge with sample applications is that they need to be complex enough to actually demonstrate a real use case. But if you make them too complex, you risk obscuring the very concepts you wish to demonstrate. And so while GoDDD may be fully functional at this point, there's still things I'd like to explore in more detail. And hopefully the feedback from this talk will help deciding which parts are worth implementing or potentially revisiting. And I'd love to get your input on the project, both on the use of the building blocks from Domaindriven Design, but also on making it a production-ready enterprise service. Pull requests are very much welcome, but this is probably one of those projects where opinions are even worth more than actual code contributions. Here you'll find some links to the things I mentioned, and also a somewhat stripped-down version of the core shipping service is also available as one of the GoKit examples, so be sure to check it out. And also, if you're interested in learning more about application structure, Ben Johnson published this excellent post on the subject a couple of days ago that I really recommend. And so Dave mentioned this morning that we need to start thinking and talking about design. Unfortunately, discussions on application level best practices can often get philosophical. Having a non-trivial a sample application that demonstrates these practices can help concretize these discussions and ultimately help spread those best practices within the community. Thank you all for listening.